Okay, hello, dear colleagues. I'm really happy that today you decided to join us at our third seminar during the set of the summer seminars that we are holding from July till the end of August. And this seminar is called Theoretical and Methodological Innovations in Network Analysis, New Tools for Managerial Decision Making. So the idea of this seminar is that we are discussing some recent developments in network analysis and bring some interesting presentations from our colleagues outside the laboratory and also from the laboratory, and we are sharing our recent advances and developments in the field of social network analysis. And we already had two great presentations of our scientific advisors, Anushka Ferligo and Vladimir Batagel. And for those of you who missed it, you will be able to find it very soon at our YouTube channel. Today, we are going to talk about bibliometric network analysis. So this is the topic that we are developing quite intensively in the laboratory, also due to the fact that our scientific advisors are also working in this field. And we have made quite a lot of research in this field already, and now we are working on the adaptation of the methodology that we use for the analysis of Russian data, so the data in Russian language. And today I'm going to tell you about some work that has been done during the last year in the laboratory in this dimension. So let's start from the very beginning. Yeah, so it's important to say that currently with such trends as transformation of the Institute of Science and the globalization of scientific knowledge, it was clearly shown that the activity of scientists cannot be reduced exclusively to their individual creativity, as, for example, it was in previous centuries, before the middle of the 20th century. And researchers who are working in the fields of sociology of science and philosophy of science, they are talking about different types of relations between scientists and even social stratification in scientific communities. And they highlight the importance of studying the social interactions between scientists and their groups. And of course, we understand that in general, in current situations, it's very important to study the development of scientific disciplines in national research systems, because this is how we can determine the effectiveness of these research systems and make some decisions about some changes which should be done in the field of science. And there are a lot of tools which were developed in such scientific areas as bibliometrics and scientometrics, and they proposed special approaches to study the development of science and social interactions between scientists. And one of the approach which is used in bibliometrics and scientometrics is the analysis of bibliographic networks. And in this case, we study such network as co-authorship, citation, co-citation, and bibliographic coupling among different groups of bibliographic entities, which could be authors, publications, journals, keywords, countries, and so on. So you can think about different levels of such research. And this bibliometric network analysis is actually what we do in the lab. And in this approach, there are, again, numerous methodological approaches and tools which have been proposed to study this kind of bibliographic networks. We can list such tools which are shown on the slide now, such as WOS Viewer, SiteNet Explorer, packages bibliometrics, which are available for R and Python, or special web interface called BiblioShiny, and so on and so forth. So probably you even have your own experience with playing with these programs, because some of them are pretty intuitive, and they do not need much experience in network analysis. And the thing is that such tools are oriented towards international databases of scientific citations. So they take as input data from Web of Science, or from Scopus, or Google Scholar, probably some other international databases. And actually what we were using in the laboratory in our research, we used a methodological approach to the analysis of bibliographic networks, which was proposed by our scientific advisors, Vladimir Batagel, Anushka Ferligoy, and their colleagues, Patrick Dorian, Luca Kroninger, Marian Sugmas, and so on. So I just made two citations, references to the works of our colleagues. However, of course, there are much more publications on this topic. And what is proposed in this methodological approach? We use Web of Science as a data source. So when we are doing this analysis, we go to Web of Science, we search for some topic, we collect data, and then when we have data in some format, we use a specially developed program, which is called WOS2PAEC, just for network creation. So we just open this program, we put our data set, which we obtained from Web of Science, and then the program is working, and then we got the set of networks, the set of files in the format which is created specially for the analysis in PAEC program. So this is a kind of workflow pipeline. So we go to Web of Science, we collect data, we go to WOS2PAEC, and then we go to PAEC and we make this analysis. And probably some of you have seen some papers which were published by the group, by the members of the laboratory. I just listed some of them where I personally took part. However, there are more publications, and you can find them also in our page in our website. And so we started developing, I mean, personally, I started working in this methodology from the project which we implemented jointly with Vladimir Batagel, where we studied the field of social network analysis. So this was the overview of the most recent publications, the most cited publications, the development of the field through some special algorithms. Then we were making the description of this field using the keyword analysis, and we extracted main journals and looked also at the collaboration structures and so on. Then we moved to the field. So, I mean, we just made everything that was possible on that data set, and then we moved to the field of iMetrics. This is actually how we called the discipline, which contain bibliometric, scientometric, webometric, so all the disciplines which somehow deal with this bibliographic, bibliometric analysis, using different sources for such analysis. And then with some of our colleagues, we also analyzed green information technology, and just recently with the colleague from the lab, we analyzed qualitative social network analysis using the same approach. Then also some papers were published in Russian language, and here you can see 3 of them. However, I also think that there should be more, but I am just a co-author of 3 of them, if I remember correctly. So we started with the research on the systematic literature review, and we used the data on the mass behavior as the example. And then we analyzed the topics in sociology with another colleague, and also analyzed the topic of healthy, здоровые города, healthy cities. So now we are working on some more publications on this topic. And what is important that in these all publications, either in English or in Russian, we were working with the data which was obtained from Web of Science. And this was the data in English language. So we were analyzing a kind of international set of publications. And of course, we are very much interested in studying the Russian subsets and Russian science and Russian scientists as well. And I remember that when I just first met with, when I just started working with this methodology, I had an idea to analyze the field of social network analysis in Russia. So it was my actually first idea, and after that we came up to this observation of the whole field. With Professor Vladimir Batagel. But I thought that it can be interesting to see at the community of Russian scientists who are doing network analysis. And that's why I was so happy to find that actually from Web of Science, you can also collect this data. And I tried to analyze it with the same approach, so the same methodological approach. So I had my data from Web of Science, and you see it here on the left. You see that some of the fields are written in Russian language. Yeah, and so what I did next was I was trying to just proceed it with WOS2PIKE program. And then I was very unsatisfied with the results, because actually what you see on the right is a kind of network file which was created with this WOS2PIKE program. And after the numbers, you are supposed to see the short names of publications. Probably something like you can see on the top, like this Daria FR, and then it would be the year and the title of journal, volume, and page. But as my data was in Cyrillic and not in Latin, then I got a lot of information, a lot of data which was read in not in a correct form. And of course, it was not possible to proceed with such data. And for some time, I just decided to forget about analyzing this data. And I just switched my attention to this English language data, the data which is transcribed in English, in Latin. So the problem that we have is that, yeah, we do have a lot of tools for bibliometric network analysis, but at the same time, the algorithms of data preprocessing, which are embedded in the tools, in these tools, are oriented towards English collections of dictionaries and cannot be directly used to normalize data in other languages. I mean that there are problems of name disambiguation, lemmatization of words, and word tokenization. And of course, there are some dictionaries in these programs which preprocess the data, but in fact, we cannot use it for the data in Russian, the data which includes Cyrillic and Russian language. And here I should say some words for those of you who are who looked at the title of our presentation. It is said that this today talk is devoted to the topic of adapting bibliometric network analysis to study bibliographic data of Russian-speaking authors. And here I should say that Russian-speaking authors can be understood in like 2 different ways. So we can talk about data in Russian language, right? And then we can also talk about data of Russian authors. And of course, there is a huge intersection in between. But actually, we can also look at the data on publications published by Russian authors, but in English. And then we can actually directly apply these methods which were developed by the colleagues. Yeah, because this data is already in the right format. But of course, we are very much focused on the analysis of this intersection. So we want to analyze the data of Russian authors, which is written in Russian language, because it's important and it can give us the understanding of the field that we are studying. Yeah, so the problem that we face is that the existing approaches can't be directly applied to analyze data in Russian language, and we need to adapt existing or develop new approaches and tools for bibliometric analysis to study this kind of data. And the methodology of bibliometric network analysis is not often used to study Russian science. Sorry. I will just, yeah, probably it's okay. Okay. Yeah, and we actually didn't find a lot of examples of usage of the methodology of bibliometric analysis in general. I mean, we have our presentations, I'm sorry, we have our publications, and also we know some examples, but I'm sorry, I just need to turn somebody's sound. Thank you. Yeah, no, it's fine. Okay, so I think you got this idea that methodology is not often used in general, and also for studying scientific disciplines in Russian scientific disciplines. So we think that if we have this approach, there will be a chance to study the disciplines in Russia, but also this methodology could be more pronounced and more visible in the whole sociological discipline, or in the field of sociology of science, and then it can be also more often used in general. So there is no such methodology, and that's why what we answer is that we need to develop such methodological approach by ourselves. We have a kind of benchmark this approach which we have been using before. This methodological approach proposed by our colleagues who use Web of Science, WOS2PAEC, and PAEC for analysis. But we can generalize this approach to a kind of workflow which will contain 3 main stages. So at first stage, we need to build a bibliographic database. We need to select it, and we need to get the data out of some bibliographic database. Then we need to construct networks for further analysis. So we need to somehow reorganize our database that finally we will get these network files for the analysis. And then on the third stage, we will just apply the methods of network analysis that we know and that we use to identify trends in the areas that we are studying. What we need to do is to choose bibliographic database, because we cannot use Web of Science, but okay, I will tell about it a little bit later, but we are supposed to choose some Russian bibliographic database. Then we need to create tools for constructing networks for further analysis, because if we are not using WOS, like here on our benchmark methodological approach, then WOS2PIKE is also not working. So we need to somehow construct these networks, and then we will apply the methods that we know. Actually, we can continue working with Pike because it's very powerful tool, but we just need to so the result of our stages 1 and 2 should be the set of files which will be which we will be able to analyze in Pike program. So we were working in this direction, and we in this in the development of this methodology in the framework of the project that we just have successfully finished. This is the project Patterns of Collaboration in the Russian Sociological Community, Structure of Scientific Schools and Possible Growth Points, which was financed by the grant of the Russian Scientific Foundation. And in this project, we were looking at the networks of collaboration, which we understand as co-authorship of a scientific article, using bibliometric network analysis. And of course, for this, we needed data on publications of Russian sociologists, and our decision was to use e-library, electronic library. But I will tell some words about the choice a little bit in the next slides. We analyzed data for 12 years, and here you can see the members of our project team. Of course, at first we were thinking how we should choose the data source, like what should be the source for the set of publications that we are going to analyze. And of course, as we had the understanding of how to analyze data from Web of Science, we were looking at this scientific database. And what was good is that Web of Science allowed us to use the original methodology, but we needed to somehow adapt this methodology for the Russian language, because I already showed you what we get if we have some Cyrillic in our data file. So we needed to somehow change to adapt WOS2PIKE to our data set. And then we had also two choices. We could use Web of Science core collection, but it contained articles in international journals, and of course this significantly underestimated the number of works that we should analyze, because if we are talking about Russian sociology, of course it's important to analyze not only the articles which were published in international journals, but of course we needed our domestic journals as well. And the problem with Web of Science core collection was that when we were specifying the Russian language for publications, we also needed to specify the topic, and also the search results didn't include articles written by Russian authors in other languages, so only in English. So that's why it was not a good choice. And another option was to take Russian Science Citation, the publications which are included into Russian Science Citation Index. And these are articles of authors in Russian and international journals. But it was very difficult to select, very complicated to select these publications, and the filtering that that exists in Web of Science is not optimal. So we were not sure that we will actually get all the information that it is possible to get. So that's why we were started thinking about other data sources, and we looked at two of them, e-library and Cyberlearninka. And as for Cyberlearning, it allowed to search in the category of sociological sciences, but we could not specify the desired time period, which was again important for us. So we came up with the decision to choose the electronic library e-library. What is good is that it presents this Russian Science Citation Index collection, so which is also published in Web of Science. So actually, this should be the same. And for each scientist, there is a unique identifier, which is called Russian Science Citation Index Author ID. And as we thought, it will allow us to solve the problem of disambiguation of authors, because each author will already have his or her identification number. And also there were different options for forming a data set. So we were thinking to search by subject, like all publications in sociology or journals. Yeah, like we could take main journals in sociology and then extract publications from them. Or we could also search for authors. For example, if author identified himself or herself as sociologist, he or she will be included in our data set. So e-library is good because you actually can think about different operationalizations of your research problem, and you can come up with the best solution to get your own data set. And our strategy was that we were searching for the scientific articles in Russian Science Citation Index journals. So only the journals which are indexed in this sub data set, let's say. And they should be written by the Russian authors in the subject area of sociology, because each article has its own area, which is connected to it. And so we have chosen this subject area of sociology, and the period was from 2010 to 2021. And the process of data collection was done through the e-library API service. And the data was provided by e-library under the contract. This contract included access to API service and the list of publication IDs. So we formulated the strategy, what we are searching for, to the colleagues from e-library, and they actually gave us the file, which included all the IDs of publications which answer to this strategy. Yeah, and our resulting data set is a little bit more than 75,000 publications. So it means that we got the list of the IDs of these publications, and then we got the access to API service and what we needed further to get the information for these publications using this API service. And we did it, and I will tell you a little bit more about it. But I will tell that for each publication, we tried to get as much data as possible. So we got information about publications, like their ID, title, pages, number of pages, DOI number, which is unique identifier of publication, financial support, which was marked in the publication, year of publication, link, URL link, reference, and citations. That citations which are, I think we didn't get citations, but it is possible to also get citations for publication. Then for authors, we collected information about IDs, affiliation, and IDs of affiliations, like organizations in which the authors are working, up to 8 people. So we looked at the distribution, and we have chosen this number of authors as the maximum. Then for journals, we also collected names, IDs, and different numbers, also impact factor, and some, if they included to WAC, WOS, Scopus, and some other databases. Also volume number, publisher, and ID of a publisher. And also we collected keywords, abstracts in Russian and English, and also the rubric code for our publications, which is actually the same for all of them, because we were searching for the area of sociology. So you see that actually this is quite a rich set of metadata, and you can construct different, you can take different parts of the publication's description to use it in your own research and answer your own questions. So then I will tell you a little bit about how we collected the data using this API service. Here you can see how it looked like. Actually, this is a link in the browser, and there are different identifiers and different services which allows you to get some information which is needed. So we were using this first and last identifiers for our dataset construction. When we go, these are some examples, like if you're using identifier to find author. So this is what you get for some authors. So which information you get. So like you have ID of author, SPIN number, name, the affiliation, and some links to profiles and so on. So this also can be used. But what we used this identifier 011 to get the IDs of the publications for some author, which actually we didn't use later, but I think that it's interesting to show how it looks like. So we have the author Maltseva Daria Vasilievna, who is me, and then we get the author ID, and then for this author ID, using this identifier, we just get all the items, all the publications which are shown on the page. So you see that this is ID of the publication, and then the year of publication, and the this is also ID. So actually you can search for some authors, and then you can find you can get the list of their publications. We made the Python parser to collect the data, and the files we were working with were in XML format, and we used our parser to process them. And here you can see the example of one page for one author. You see here the surname and the name, and then there would be the affiliation and the title of the publication. And then we will have the journal title and also some information about this journal, like if it is included in Web of Science, Scopus, and WAC. Then it's a publisher, the year, and the number of the journal, and papers, and so on and so forth, and also keywords and abstract and so on. So actually, this is the whole metadata that is shown for each publication. And what we did, we just extracted all the information that we got, even though our research was focusing on the analysis of collaboration structures, and actually we would need just the probably the ID of publication and the authors who are mentioned there. But we thought that it's a nice idea to collect everything which is possible. And as I already told you, what is good in eLibrary is that each author who is registered in Russian Science Citation Index, Российский индекс научного цитирования, is supposed to have a unique ID and is supposed to have affiliation to organization. And organization is supposed to have a unique ID. And we are very happy working with this data because we thought that it will help us to simplify the procedure of data processing. For example, here you can see the RINS author ID, which is shown here and there. And then we have the author and affiliation of this author. And then if we click on this affiliation, we will also get the ID of this affiliation. But when we got the data, these 75 plus publications, it turned out that there are only a little bit, about 20,000 of authors who had these unique IDs. And they correspond to 30,000 of affiliation titles. And these 30,000 affiliation titles have 1,500 unique organization IDs. Also, 20% of authors and 32% of affiliations had a value 0 or none in their ID numbers. So it means that actually it turned out that for quite a significant part of our data set, we actually do not have these unique IDs. And of course, we needed to somehow work with it. When we started working with data, started the procedure of pre-processing of this data, we encountered some problems, mostly with authors and affiliations, because actually now we were very much focused on this analysis of collaboration and we didn't look much to other fields, but I think that it should be okay with them. But we found the problems which we called the problem of order 1 and order 2. So the problems of lack of available information and also the problems of data inconsistency. It was important to deal with these problems to solve the problem of authors disambiguation. Because it's important. It's an important issue in the field of bibliometric network analysis to merge the same authors and not to merge not the same authors. And for this, actually, the ID is a great option to solve this problem, but also for this, we can look at the affiliations of authors and compare them, and then to merge some of the authors, because we can understand that this is the same one. And actually, there are quite a lot of ways how to deal with this problem of authors disambiguation, and we also proposed our way to deal. So now I will show you some problems. I will just describe some of the problems that we faced. So these are the problems of order 1. So problems of lack of available information, which are so at first we should say that not all of the authors appeared in the dataset are registered in this Russian Science Citation Index. And of course, if they're not registered, if they go like co-authors of authors which are registered in this database, or if they publish their article in the journal which is included in Russian Science Citation Index. So it can happen that these authors are not registered, and that's why they don't have their IDs. But for some, even registered authors, ID is not always successfully attributed. It may happen that some registered authors also don't have IDs or have incorrect IDs, some like misspelled IDs. Some authors who has IDs don't have affiliations. Some affiliations don't have their unique IDs, as these organizations were misspelled, for example, when somebody was typing this into the database. So it means that such organizations in principle registered and they have IDs, but they are not attributed to these misspelled ones. And some affiliations don't exist because the organization is not registered and do not have this ID. And due to the lack of information, we got 0 or none in the fields which were in the fields of authors IDs, affiliations, and affiliation IDs. And of course, we should solve these problems using some tools for disambiguation. And here on the right, you already see the example of more than 400 affiliations which are associated with High School of Economics. And they have different names and different IDs. And we needed to work to find these unique titles and to merge these titles into one single organization. Yeah, and also there were few other problems of order 2, which are not so large, but it was important to solve them on the first stage to be able to solve these problems of order 2 or order 1. So, for example, we found that in some publications, hopefully there were only 35 of them, the authors are not presented at all. And of course, we needed to manually check it and to look what is happening there and to either insert this information into the database or to remove these articles out of our database if they really didn't have authors. Then we found some problems of in the field of initials, so where we could find something like candidate of sociological science or the initials and part of the surname. So we needed also to work with this. Then we had some problems with length of the initials in Russian and length of the objects in the last name cells, because sometimes both first and last names were found there, especially often for authors with non-Russian last names and first names. So some foreign authors would appear only in the surname cell. And of course, where possible, we were trying to change this automatically, but in some cases, we needed to take this data and look at it and to make some changes manually. But actually, I should say that the maximum number of lines that we were looking at was like 300. Another file was with 200 lines. And so I think that it's not really a problem when you are working with such a huge data set. So we found some, we came up with some decisions how to solve some common problems that we encountered with our author names and authors affiliations. So we, for authors, we manually checked some information and added information to publications which didn't have authors, and also solved the problems with misspelling of some IDs. And for affiliations, we set the names of organizations without ID to some canonical forms, and it helped us to merge them into single affiliation. And for affiliation IDs, we corrected organization names and compared them with those which had IDs, and attributed these IDs which already existed to this merged new affiliations. And actually, how, and actually the main salvation of the problem was that we created new IDs for publications, which included Russian Science Citation Index author ID, which is given by eLibrary, then initials, then first 8 characters of surname, and the ID of affiliation. So this is something something that you can see on the slide right now. What we did, so we merged different, so we created this unifying IDs, and then we compared them using some special metric, which is called the Merau-Levenshtein distance. The metric is equal to the number of characters that differ between the two strings. So like here you can see value 1 and value 2. This first line, there is only one difference in these two in these two unifying IDs, and it means that actually they are very similar to each other. And when we had 100% of similarity, of course, we could merge these IDs. But if we had some ID which were very close to each other, but not fully, we just manually checked these cases again. And strings with a metric value of no more than 4 were considered potentially identical, and we were checking them. And the result was that we actually increased the number of author IDs to 95%. So it means that we gave the unique this author IDs to those authors who didn't have them, but they were registered in Russian Science Citation Index, and they had their own IDs, but somehow they were not attributed to them. So we greatly increased this number of author IDs. And for affiliations, we decreased them a little bit, affiliation IDs, because there were some misspelling and some problems. And also we decreased the number of affiliation titles, which means that, again, we merged those titles which were the same, but just were written a little bit different, in a little bit different way. And now I'd like to show you the workflow that we created. So we actually uploaded all the codes that we used to a special repository on GitHub, which is called Collaboration. And there, anyone who will go there will find our materials on this project, which includes actually 4 main types, 4 main files, and also 1 extra file. So the files are called are titled in English, but here you can also see the description of the files. So I will start with this number 1. So this is the code which can be used to upload articles via eLibrary API. So this is what we use to get the data. Then second file is file which was used for this pre-processing the data and dealing with these problems of authors and affiliations disambiguation. And then we have the file for the analysis and creation of network files. And now I just propose us to go there and to look a little bit more in the files. Just a second. So now we are on this in this repository, and so these are these 4 files which I mentioned. And if we go to them, we will see quite well described and detailed description of what we were doing, especially for the first and second stage, because analysis is analysis, but we thought that it is really important to write down all the all the problems also that we encountered during the data collection and data pre-processing. So it is in Russian, but I think that even if, because of course we are oriented towards the Russian audience of scientists, but I think that if somebody who doesn't know Russian will be interested, I think it's not really difficult to translate it. So our process of data collection using API consists of 3 steps. So at first we are preparing, then we are collecting data and saving the data. So here you or somebody who is interested in it can find how to get all the libraries which are needed, and also some hints about API address and so on. And then also there are some hints about data collection, because it can happen that due to some problems with internet connection, the process can stop, and then our colleagues, Lika, actually, yes, it was prepared. This file was prepared by Lika Kapustina, and she wrote down the detailed description of the code, which was done by Lika, Vasily Savashenko, and also Lev Tsipis, our colleagues. And Lika also made some hints here, like what if you lose your connection, what you can do, and so on. And there, this is what we actually collect for authors. Yeah, you see that author ID, affiliation, last name, initial, affiliation, and also in English, last name, initials, and affiliation. And we had it up to 8 authors. Then I think this is the code to collect the data for titles, for abstracts, keywords, and so on. So all the parts that I described now in the presentation are available here. So there is a code how we get this information. And then, so this is the example of our database. Yeah, let me scroll it, move it here. Yeah, so these are all the fields that we collected data for. And then we save these files as CSV and Excel files, which can be further analyzed. This is what we get for the collection of data. But of course, what is important is that you need to have the access to eLibrary API service to use this code. Then I will also show you this file which has number 0, because this is the code to collect the data on the IDs of articles of some authors. So you remember now in presentation, I was showing that it is possible to get all the list of all publications for some certain authors. And so this is actually how it can be done. Again, this is the code. And if somebody's strategy will include selection of authors and then collecting data. I'm sorry, this is a long line. Okay. If somebody will be interested in collecting information on articles for some authors, so this code can be used. So now you see that we have, so this is paper text. And this is actually the same. Okay, so finally you get author ID and paper ID. and paper year and paper type. And then you also save it as the separate file. Why we did it? We actually thought that we will enlarge the data set that we got from eLibrary by just taking all the authors who are registered in Russian Science Citation Index, who has publications in sociology, and we will collect all the publications which they have. So we will just get extra publications for them. We actually did it, but then we decided that it's difficult to merge to these data sets, and we decided that, okay, probably we will analyze it a little bit later. I mean, merge from the interpretative point of view. So we decided just to stay on one decision, how we make the data set, one approach. Wait, sorry. Why we made it is because it turned out that in our data set, for example, some, of course, we checked for ourselves, and it turned out that some publications are included, which are written in the journals in the area of sociology. But, for example, some of my publications, which are written in Scientometrics, they are not included because they go in another category. And that's why we thought that it may happen that for some authors, they will be the same situation, so that they are working in a little bit different areas and not all of their publications will be included. Okay, and now let me just go to the file number 3. Yeah, this will be number 2. So this is the pre-processing of data, and we are describing here which problems we got during our pre-processing. And for example, here you see that we had these nuns, and we were making some decisions how to work with these different problems. And also, yeah, I think that I will not stay too much on these small problems that we encountered. In general, I mentioned them, but the thing is that in some cases we had the zeros, nuns. In some cases, transliteration was not done nicely. If, for example, we have this letter H in Russian language, then we needed to change it to H in English, because then otherwise the surnames and names which were translated into English didn't go well with this transliterated ones, because we were transliterating our Russian, the data in Russian. And so this is about transliteration from English to Russian for authors' initials. And let me find something interesting. So for example, yeah, in some cases we had initials in the same cell as the surname, like here. So then we just put initials in the different cell, and so on and so forth. And also we had some cases like this, like candidate of sorts, case sorts N, candidate of sociological science, or some this complex this complex initials, and we needed to also make some approach how to work with such cases. And you see that, yeah, we successfully made these changes. So for example, if the name was full, we were writing the short, only the first letters, and so on. And Yes, in some cells, the information was supposed to be in English, but it was in Russian, but in others, it was supposed to be in Russian, but was in English, and we also needed to change these cases. And then some manual work was done, but actually you see that these are really not such huge subsets. And then there is a part 2 with the which proposes the way how to work with the affiliations, but so this is the work in progress, and soon it will be it will appear here as well. And then we have the file of data analysis and visualization. So this is just the analysis of data sets. So this is not the network analysis yet, so just some descriptive information. So this will be soon presented in other presentations. It was already presented partly, and soon it will be presented in other presentations and also in the articles. So I'm not going to stay much on this part. And then also we have the file saying how we are going to save the files into PyEC format, because we were making the analysis in PyEC. So this is pretty short actually. So not really a difficult thing. Okay, so now I will come back to my presentation. Wait, that's already closed. So we were here. And then I will also tell some words about this subset of data of Russian authors, which is not written in Russian language, but written in English. Actually, I said at the beginning that it's relatively easy to analyze it because we know the approach, how to do it. But actually, there are some problems which can occur, of course. And now we have such data set, and we are trying also to make this to create such methodological workflow. So we have the data from Web of Science, and now we are trying to analyze it with PyEC and also with WOS viewer. And so these are the publications of Russian scientists. So all publications for the country Russia, which are published, which are included into Web of Science database in time period from 1991 to 2022, and this data was collected by our colleague from Czech Republic, Dalibor Fiala. Yeah, and I just mentioned here two main organizers from our side, but actually we have quite a group working on this project, and soon also we will be making presentations with some of the results of this project. And the idea is that we will analyze the development of Russian science based on this bibliometric based on the bibliometric analysis of this data. So this is more a kind of exploratory data analysis. So we have the huge data set, and we are interested in making the analysis, the whole possible analysis that we can make. And we started working with this. So we have data in Web of Science format, and it means that we can try to use WOS viewer to analyze this data. And we already faced some problems, some problems with, again, authors and affiliations names. And also now we are working on the, we are going to propose some decisions like how to solve these problems. So first, we found out that for authors, there are not unified records of surnames, and this creates duplicates of authors. So like you can see here, a little bit, the surname is a little bit written a little bit differently, and that's why this is encoded as a different author. However, it looks like this is the same one. Then the problem can be with format of the full name entry. In most cases, these are records of the type surname. I'm sorry, here is, so it should be surname, name, and patronymic name. But in some cases, the names and patronymics are written in full. So sometimes there is an entry, not surname, name, and patronymic, but surname. And yeah, you see that EO, like имя, отчество, without dots. And again, this creates duplicates of authors. And also some problems with patronymics. They can be written in the first place, like Andreevna, Kazak Anna. We actually found it with Valerievich, Radaev Vadim. And some initials can be in the first place, and then they can be surname after a comma, so like AN Yershov. So this creates some problem. Also, some names are written not in the first form, like именительный падеж. So like Andreyashiным Nikiтой. So it was written by Andreyashiным Nikiтой. So we need to work with these authors' names. And also for affiliations, we also found some problems, like they can be address instead of the name of the institution. Also heterogeneous transliterations of Russian language names, like Gorky, Gorky. Then you can see Adygea written in different way, and Herzen, Gerzen University. And some heterogeneous abbreviations like Tech, Technol, and Technical, Sport and Sports, Literature and Literary. And also a huge problem usually arises with different branches of Russian Academy of Science, because they are always listed as separate affiliations. And the same affiliation can be written in multiple languages, like Academy of Science Russi, Acad Rusas Sciences. So it is in Latin, but it is not transliterated in the same way. And there is a suspicion that not all affiliations have full names, such as National Research University, like written here on the slide, but it's not said what is this National Research University. So some part is missed. And now we are working working again on the workflow, which will help us to solve the problem of disambiguation for this data for both viewer. And we will also look what will happen if we analyze this in PAEC and using BOS2PAEC program. We haven't done it yet, but this is also something which should be done soon. And so this was about the data and the selection of data source and creation of database. Then actually we have two more stages of network creation and network analysis, which are actually very clear, because we already did this analysis, and we especially create the files in such a format which we will be able to use in PAEC. And so using these networks that we created in our project, we can construct different types of co-authorship and collaboration network, but not only these networks, but also networks of keywords, co-occurrence, journal citations, author citations, publication citations, and so on and so forth, as much as we can think about. So we can take different entities, and as they are presented in the format of a table, so we can always construct two-mode networks out of these tables, and then these two-mode networks will be linked because they share the same part, like authors or works, and we can construct different types of other networks. And then as for data analysis, we are oriented towards the analysis on 3 different levels, like micro, when we look at the metrics when we look at the network measures of some certain authors, and we just highlight some important nodes, like the most collaborating authors, the authors who has the largest number of publications and so on. I mean, talking about our analysis. Then we can also go to macro level, so we can look at the general characteristics of collaboration using some descriptive statistics, just to see, for example, the distribution of some network measures, and to make some conclusions, like to which model our network correspond to. And also we can use some methods such as block modeling also to look at the structure that we analyze, like from above. But also we can go somewhere in between to so-called meso level, and to find some important subgroups in the network through different approaches which exist in network analysis, such as line cut, which is very simple way just to get the most collaborating authors, for example, or islands approach, which is used to get some structures of nodes which are connected more to each other than to the other parts of the network. And actually, this is what we are doing now. Just to conclude, we are working on the methodological approach or workflow of bibliometric network analysis for Russian data for Russian-speaking authors, which is based on 3 main stages. So we select and build, we select a data source and then build a bibliographic database. Then we construct networks for further analysis, and here we put a lot of attention and resources to data pre-processing. And then we just get these files, which can be then used for analysis in Pike or VOS viewer. So this is the same part as in general approach, but here on the first and second stage, we need to find some solutions. Yeah, actually, that's pretty much it, what I wanted to tell today. And I wanted also to say that we are working on the, so we are finalizing this comments and notes that we have in our GitHub repository. And we are thinking to somehow register it as a project, as a product, so that it can be used by other researchers. And of course, we will be happy happy to disseminate this. And we even think about making a kind of package, for example, for Python, where all these procedures will be included as functions, and we will just be able just to select some functions and to make some procedures. And we will be able to make some procedures which can be typical. And of course, if somebody will need some special thing, probably he or she can also add something to this to this package and to develop it somehow. So we are very open actually to this kind of collaboration, and we will be happy to share the results of our work a little bit later. And I just wanted to make an announcement that there will be some further presentations on this topic, and in the end of August, like in 1 month, we are going to present the results of the project of the analysis of Russian sociologist collaboration. So now I was talking about the kitchen of getting data and pre-processing it, but there we will focus on the results that we got during our analysis. And also in the end of August, there will be a presentation of Irina Pavlova, who will be talking about comparison of software for large information network analysis, different packages and different programs like R, Python, Orange, Pi, Gephi, WOSViewer. And this presentation will be based on the data set which is taken from this WOS project, which is the project on the analysis of the whole Russian science. So you are invited to these talks. If you came today, I do hope that you are interested in bibliometric network analysis, and it will be nice to have you at these presentations. And also there are some publications in progress, and so we will be also sharing the information when they will be available. Okay, that's it. I think there are some questions. And please prepare your questions, and you can also just switch on your microphone and talk if you want. Okay, now I will focus on 5 questions that we have in the chat from Violetta Habibulina. Please clarify on limitation up to 8 authors comes from. We just, I think we just looked at some test data sets, because actually we had different iterations of data set collection, and we just found out that in the most cases we have like 1 or 2 or 3 authors, and the maximum was I think not more than 8. And that's why we just stopped there. I will just show you some. No, I understand that you can't use your micro and camera. I was just telling to other participants that if you'd like, you can just switch on and talk to us. It's not necessary to write it. Yeah, I will just show you this very nice graph. No, not graph, but graphic, so picture that we created. So this is the distribution of the number of authors in different time periods. And actually you see that 8, 7, 6 authors, this is just a very, very small amount of publications has this number of authors. So we decided just to leave 8 as maximum because yeah, it was quite a huge database, and I think Vasilisa was working, Vasilisa and Lika and Lev, when they were collecting this data set, it took a lot of time, and that's why we needed to somehow to put some maximums, because then it will proceed some other authors. So we decided just to have some maximum number, but actually we can look at the publications which has 8 authors and to check manually if there are more than 8 authors. I think it can be done, and for some clarification, it can be also mentioned in some in the article that we are preparing. So this is a good question. API stands for, I don't know, how is it? I'm sorry, I need to say the API.
Vasilisa has already answered in the chat. So there is an answer at the bottom of the chat, yes.
Application programming interface. Yeah, so I never thought about it. I just get used to use API. Okay, so this is some service which help to deal with some applications. So like ВКонтакте, so there is the API, and you can go there and you can get some information which is available there. So the same for e-library. So they open some data. So you go to this API service, and if you have access, you can get some information which they decided to share in using this API. So actually you get just the access, and what you're doing there, what you're doing next is that you are getting the data by yourself. So you are free to choose any like configuration of what can be needed. What have you decided regarding not only multiple affiliation, but changes over your period 2010-2021? Even if you escape the problem of escaping migration, it should, yeah, because we escaped this problem because we have data only to 2021. Yes, but actually I should say that it should be interesting also to look at the same kind of data a little bit later, because we expect that there will be some changes. I wanted to show you this case. So for example, I hope you can see my presentation. So here you can see the example, and first will be author ID, which is given by e-library. Then we have the name, first letter of name, and then surname of Andrei Korbut. And then we have affiliation 1 and affiliation 2. So actually what we did, of course, we could not trace the we could not trace like how the affiliations were changing through time. In this case, but at least we have the information that there are different affiliations, or the author has different affiliations. And it also helps to interpret the results, because sometimes we see that there is some author who is connected to the group of authors from the university number 421, and another group will be the authors with this affiliation. And we can actually see that the author was working in both of the organizations. So this is really a nice idea to, I think, to extract or to insert the information on affiliations in such way. And it also helped us in case of merging the similar IDs, because, for example, it could happen that it would be the same thing, but without this last affiliation, but it will be only one affiliation. But using our technique, we will get the information that these two IDs can be similar, and we need to check this. So this is how we deal with the multiple affiliations. But of course, we have the information on publications in time. So technically, we can split our data into some periods or even each year. And then we will have the information. I mean, we will make the same procedures for these subsets. And then we will have the information like in which year the author had which affiliation. So probably it also can be done further. Okay. Please clarify on definition of Russian sociological authors with regards to scholars from former Soviet Union publishing in Russian. Yes, if they are included into Russian Science Citation Index, if they are registered, and if if they wrote publications in sociology, in the area of sociology, in the journals which are included into Russian Science Citation Index, so then these scholars, I think, should not be here, because we were specifying that we need authors from Russia who wrote that their country is Russia. Without affiliations, like classical example of independent sociologist Boris Doktorov. Yes, but if Boris Doktorov actually is included into this data set, I've seen him, and it will be just specified that there is no affiliation for this author, but he will have this. He will have his unique ID given by eLibrary, and in this case, it will be something like none in the end, like here in presentation. In the end, for Vidas, we have none, so it will be the same thing. A lot of sociological work, SAE, is done under such fields, dissertation councils like education, political science management. Are you sure that all these articles are under sociology in eLibrary? No, I'm not sure. Yeah, so that's why actually this is a question for further discussion and for further checks. But I think that, so this is the first work of this type, and I think that it's really important to make it not as an ad hoc research, but as the but to provide this methodological framework, and then we will be able just to get data for other fields and to analyze it in the same way, to combine the data sets and so on. So yeah, we also noticed that some publications can be missed. And 5, most difficult question on financial payment to a library for the dataset. How much in proportion of RNF grant? Is it a unique dataset according to your tasks, or a library provides templates? Yes, it was the most, it's not only the most difficult question, I would say that it was the most difficult task during all the time of the project implementation, because it took us literally half of the year to make this contract, because we were making it from, I mean, two organizations were included. One is eLibrary, another is High School of Economics. And both of them really, yeah, for both of them, it took some time to согласовать, I'm sorry.
To approve, maybe. To approve.
Yeah. Thank you, Irina. Yeah, to approve some parts of the contract and so on, and it really took some time. And even I think that's why we were a little bit late with the analysis, but finally we managed. But we really worked hard in recent months. And talking about financial payment, I think it was, as I remember, it was about 200,000 rubles for all the data set, and they count the payment is counted according to the number of publications that you are going to have in your subset. Yeah, so I think it's pretty okay for the grant, because for the grant, it was the grant for the young researchers for 3 million rubles for 2 years, and we paid 200,000 rubles for data. I think it's pretty manageable. Yes, and this is a unique data set which is created especially for us, for our search query, and we were discussing it, and finally they made us a list of the publications that should be collected from the API. Okay, so Georgi, thank you. API to be a restaurant waiter. Think of API to be a restaurant waiter. Think of the server to be the chef or kitchen. You order food via waiter, which chef prepares and gives back waiter to you. So send request to server via API and get the response back. Yeah, thank you, Haranya. This is a good description, I think. Number 5. Yeah, so 200,000 troubles. Yes, yes. Template with change in field. Looks like label than here quality of it. Template with change in field and time period. No, they don't have. I mean, no, they have. They have the these different identifiers in the API. Yeah, like now it is shown on the slide, and you can go to different identifiers. And you can use different identifiers to get different kind of data. So somewhere you will get only the list of the publications for some author. Somewhere you will get the full, you will need to insert the ID of publication, and then you will get the whole page or describing this publication and so on. So you can see this is get item ID, get author ID, find author, get author, and get item 2. So we just used this, actually 026 was the main identifier for us. Yes, and looks like elaborate don't care on quality of data set provided for payment. How to say? I think it's a difficult question, and we were also discussing it quite a lot. We think that the problem is that in some fields requires manual writing. So that, for example, some person working in the library or author by himself or herself can write down some information. And this is the devil is in details. So there is the devil, because authors can write the affiliation in different way, or some bibliometrician can also write something not in a correct way. Probably sometimes some data is extracted automatically, but it actually needs some checking after this, but probably it is not checked. So actually we think that with our approach that we proposed, we can even make some propositions to e-library so that they can use some code to check the data and to find some problems, and then to go there deeper and to make some changes manually. Yeah. But I think this is a very widespread problem for the databases and libraries and electronic libraries. And I think that you see that in Web of Science, we also find a lot of problems with authors and affiliations. Yeah, so the best decision will be just to unify everything as much as possible, to have the fields where you can choose something but not write by yourself, and also to have unique IDs for authors, affiliations, organizations, publishers, and so on. So this should be done. Even the best thing would be to have a general identifier for the author, like ORCID number, which unifies, to which all other IDs like Scopus ID, WOS Researcher ID is attached. So it will really help us to identify authors in the right way, and also will help to use data from different databases, because otherwise we do have some problems and we need to solve this problem of authors disambiguation. Okay, I also see the hand from Ivan Alexandrovich. So please, Ivan.
Thank you, Daria, for the description of your strategy and methodology. It's cool, really. And I have another difficult question that haven't easy and clear answer, I think. What kind of meaningful hypothesis or tasks can be formulated for or solve by your methodology and by your strategy? I understand that it can be bibliometrics, tasks and aims, but if we are talking about scientific community and communication, internal communication, what kind of meaningful tasks we can solve by this method?
Yeah, thank you very much.
Just to reflect, I understand it can't be a simple answer for this.
Yeah. Thank you so much. Yeah, generally we can answer to a lot of questions which are connected to the development of scientific disciplines or like social interactions between scientists. And some researchers are saying that using like citation and co-citation, citation and co-citation analysis, we analyze the social structure of the scientific community, and studying bibliographic coupling structures, we also get the cognitive structure of the field, like generally it can help us in our case. In case of studying collaboration between authors in the field of sociology, it can help us to get the understanding of some groups in the field and how these groups are connected to each other. They are connected to each other? Is there, for example, a core group and some periphery group, which is talking about sociology, there is a nice work of Titaev and I forgot, I'm sorry, about province and capital sciences. And they actually describe that there are three types of in sociological community in Russia, we can distinguish three groups. And one of these groups is a so-called capital sociology. So these are the sociologists who are working in Moscow and St. Petersburg, and they have a lot of contacts with the foreign researchers and so on. There is a periphery and also the provincial, two other parts of the sociological community. And this periphery is looking at the most central group, the capital group. And for them, it's important to have connections to them, to visit them and so on, but it's not working vice versa. And actually using the strategy and using bibliometric network analysis, we can look at the general structure of the field, and we can identify some core groups and some we can actually check we can check the hypothesis about existing if these groups exist, and like how widespread is this part of the periphery, and if there are some provincial groups which are just connected, where the researchers are connected only to themselves and do not have much relations to the central to the capital, to the group from capitals. So we can look at the global structure of this collaboration network and to make some understanding of this field. But also we can, I think it's interesting to look at it in the dynamic, because we can notice some changes. So as I already showed you this nice picture of trends of number of articles by years, actually you see that in 2010 we had 80% of articles written by single authors, and now in 2021 we have 55, as I remember, 55% of articles written by single authors. So there is a decrease of such articles and increase of articles written in collaboration. So we can think about the trend is changing. So the people start, the researchers start making more articles written in collaboration. And if we will compare different disciplines, we will also be able to see like what are the trends in different disciplines. And also another interesting research came into my mind. So this is the project which was done. This is one of the few projects which used bibliometric network analysis for the analysis of Russian data. And it was also devoted to the analysis of sociological community. So made by Mikhail Sokolov and his group in St. Petersburg. And they actually distinguished three groups of researchers oriented towards foreign research and foreign organizations and publishing in international journals. Those oriented towards domestic sociology and domestic journals and who are not having much contacts with the foreign researchers, and also some group in between them, which somehow connect these two groups, which otherwise are not connected at all, if not the members of this group. So I think that we can make some interesting conclusions out of these results, but what is important is that actually the idea of this project was that after getting this information on network analysis, we will also go to make some interviews with some sociologists who are working in the field and some researchers who are studying collaboration. And we will try to make some explanations of the results and so to get some interpretations to these structures that we are getting. So we think that now we will finalize the analysis and present it, and probably in autumn it will be nice to make larger presentations to larger audiences and to make some kind of discussion about the results and some probably even thinking about some hypotheses that we can also test later.
Thank you. Great. I think I have one idea for the research and for further analysis, but a bit noisy here right now. And it makes a bit difficult for me to formulate. I think I can reflect this idea more, a bit more, and I wrote you. I think we can analyze the relations between dissertations and articles and relations with articles after the defense of the dissertation. And it makes clear the scientific way or the usefulness of the dissertation for the scientific career for person.
Yes, this is interesting, great idea, and Ivan Alexandrovich, thank you so much.
Because in any dissertation we have some articles inside.
Yeah. Which were prepared during the thesis preparation. Yeah, sure. Actually, what we noticed when we were making the analysis with Vladimir Batagel, we were looking at the temporal distributions of the number of articles that the author have. And so we were analyzing some well-known authors, and we were looking like how the number of their publications rises and then fall down, and then rises and then fall down. And it was really funny when Vlada was explaining this, like, here he was defending his thesis, then he was just normally working, then he became a professor and he got new students and they were defending their thesis, and then again it went up. So actually, yeah, it's interesting to see such distributions. Okay, thank you very much, dear colleagues. It was really nice to present you our results and to get questions and comments. So we are happy if it was interesting for you. And yeah, thank you so much for being here for almost 2 hours. I think now it is time to have some rest and have some evening. Yeah, okay. So I'm stopping the, yeah, okay, so goodbye everyone.